So with that, in the remaining 50 minutes or so, I'm just gonna, unless there are questions or requests, I'm gonna use that time to basically play with the ChatGPT. I will explain maybe some of the details a little bit. I think I briefly mentioned this at the orientation session again. But just to briefly recap, so what I have done in the past, I've been playing with the ChatGPT for like in these sessions for like a year and a half. For the first time ChatGPT came out, I was just using it to get. I think there's a playlist here. Using it to get a kind of feedback on conceptual questions. So is that the right one? Yeah. So there's one where I'm just me myself commenting on conceptual questions, and I think for this class I've never done it with the physics 4B conceptual questions, but 4A and 4C, one spring semester, yeah, spring 22-3. ChatGPT wasn't as good with the physics as it is now, but I thought it would still be good enough to have it answer conceptual questions, and it did decently. That's here. But starting in the fall semester is maybe not fall semester. At some point, ChatGPT was getting good. Oh yeah, so I did do physics 4B conceptual questions, fall 22-3. So I think it must have been either spring 22-4 or fall 22-4 when I thought it's getting good enough that you can actually use it as a tutor. You can rely on it to actually answer quantitative, somewhat complicated physics questions that's in your problem sets. So that's what this playlist has, physics problem solving with the ChatGPT. So last time I've done this with the physics 4B was the last fall. Yeah, so about a year ago. So that was fall 22-4, and back then I was using ChatGPT 4.0, and I think the structure of it has remained the same over that year. So when you ask ChatGPT a question, its default is to just answer the full thing right away, because that's what most people like. So at the beginning of the session, I would do a quick demo, like asking the full question, how you get the whole question, and it won't really help you learn, because everything you do in this class for the written work, you should really treat it as a practice, to practice for the required one-on-one meeting. And unless you are learning how to solve physics problems, you won't be prepared to answer my questions at that meeting. So as part of these demos, you will see me basically, not these, but these, you will see me having a prompt that says, hey, please don't give me all the answers right away. I'm really trying to learn the content to prepare for the one-on-one meeting. Just help me with the next step. And I realized over the summer that that's the kind of situation that custom GPTs are for. So with the custom GPT, I think I didn't show this portion in the orientation session. So with the custom GPT, you can give it basically a set of system instructions. So this is a custom GPT I'm setting up for all the physics 4 classes, so that all the engineering physics is one kind of content. And this is actually what I was working on last weekend, updating it for physics 4B content. So there's a lecture summary, which I will show briefly. You don't have access to it, but not for any like secrecy reasons. I just don't think the document itself is all that helpful to students. But it's something that's meant to be helpful for tutors, which ChatGPT Connect has. So within this system instructions for the custom GPT, I basically tell it, they come to ask for its help, learning how to solve physics problems, preparation for the one-on-one meeting, and only give the next. So this is kind of version of the prompt that I would give at the beginning of those sessions. So the kind of my main idea in putting this together was having something that would kind of act as a tutor as a default. Like you don't have to start out with a special set of instructions, as in you don't have to start out with a special set of instructions, because those special instructions have already been given to this custom GPT. Now, since I had that idea, the OpenAI did come up with the study and learn mode in ChatGPT, which I think if you've used it and if that somehow works for you, then great, use it. I guess one advertisement for this is if so one advantage that this custom GPT can have that the ChatGPT's study and learn mode 1 is this knows exactly how things are covered in this class. So let me show you what this lecture summaries has. So let me see if I can get to the right place without showing too much things. I think I need to go sort of here. Here. So this is the lecture summaries file. It's incomplete, and the version that CoA Physics GPT has is this exact version. This is a folder where I'm keeping track of different things I'm putting in there. Like that. This interface has 0 version control, so I have to keep my own document of prompts to have some level of version control. If there's a regression, I have to go back and fix it. And this is gonna be a project for the whole semester. So this is the lecture summaries. The file that CoA Physics GPT has access to. It covers through lecture, I think 15, through the end of electrostatics. So, so even though we want to thermodynamics for a while, especially analyzing heat engine cycles, I thought I would just go in order. So once we get to electricity, so we are going to start with the lecture 7 next week, just skipping ahead to electrostatics. So this is the one advantage that CoA Physics GPT has over the any non-class material. It has these summaries, and nothing in the summaries is something that's secret. It's a summary of your lecture video, and if anyone wants it, write to me. I'm happy to share it. I just didn't want to share it with the whole class as a default because I didn't want people to get wrong impressions. Sometimes people look at the summary, I think they can simply read through the summary and that'll give them the necessary information. I do not believe that's the case. You can skim through it, read through it, and you will probably forget most of it almost immediately. So when you experience it in the context of lecture with a full story, that's different. It's not saying I mean, even with the lecture, you watch the whole lecture and then you can still forget that immediately. But I think a summary is actually worse. So, but if anyone wants it, let me know. I'm happy to send it to people individually. But this is what CoA Physics GPT has access to. So that's the kind of the one advantage. It can give you basically exact lecture references when it's telling you review this or that. Did I only go through lecture 14? I thought I went through lecture 15. But 14, I guess that's right. 15 must be starting with the circuit. So yeah, that's kind of the setup of the CoA Physics GPT. This is just a copy of what was on the other screen. Yeah, and that's this semester syllabus. So with that long intro, kind of exposition of what this thing is. So let me just I'll continue alpha testing it. Do I say alpha test here? That's basically what I'm doing. When ChatGPT first came up, people were talking about prompt engineering, and I thought it was a joke, as in like, what's that? It's not programming, it's not coding. But I do think writing kind of proper system instructions for generative AI, that I can imagine that being its own discipline at some point when things settle down and there's an actual theory behind it. In the meantime, so I am working on and improving the system prompts throughout this semester. Hoping it will be better at the beginning of next semester, and as part of that, I kind of have to test it. This is basically an alpha product at this point, so I'm gonna say it's alpha testing, and I'll be testing out how it responds to different situations, different questions that a student might be asking, and kind of watch out for when it's doing things wrong and kind of fix it for the next update. So I should be updating the material for this GPT in about a month or so. I'm hoping to be about 3 weeks to a month ahead of the class each time. When I'm uploading the magnetostatics content is when I'll be that's when I'll be thinking about maybe tweaking some of the system instructions. So I have CoA Physics GPT on the right side of my screen. Let me get to this. As test student, I think I do need to clear some module items, but most of those are easy to clear. Yeah. So here, contribute requirement, that's the one requirement that I don't know how else to clear other than to do this. I have to reply. So I'm just gonna say clearing module requirement for the test student. I guess you can make a similar type of reply, as in you just reply with a nonsense like this. Then you get 0 point, which I don't know. It's your grade is basically determined solely by the required one-on-one meeting. If you want to skip an assignment, sure, skip it. I care a little bit, but not enough that I'll threaten with things that I have no intention of following up on. Okay, I'm at the problem set. So let me do this. So this used to be the part of the demo, last year or last semester, depending on which class you are looking at. Me just demonstrating, don't do this, because if you do this, it'll just give you the answer right away, and you won't learn anything doing it that way. Used to be that demo. Right now, it's a test. So for this class GPT, if I give it like that, just screenshot, don't say anything, will it act like a good tutor and walk me through what I should be doing, or will it still need additional tweaks to its system instructions? Let's carefully set this up. X in Celsius, Fahrenheit, okay, matches, good. Recall the conversion, good. Mistaken reading means that true Fahrenheit value means, and the problem said, right, true Fahrenheit value should be that, but the problem says that is, yeah. So I guess what it's doing is it's doing some of the process that you should be going through, turning the English description here into a mathematical expression to which now algebra can be applied. And I think going up to here, there's a judgment call to be made, and I hope it just stopped here and didn't solve for x. Did they solve for x? They solved for x. Yeah, so I gotta figure out. I need to somehow strengthen it so that it doesn't do this. So this is an easier question than usual. It's an easier question than usual, so maybe on a harder question you won't do this, but I have to, I do think I still need to tweak the system instructions so that it doesn't do this. But let me pose this as a scenario. Let's say you are working with a classmate. This question, there are two versions of this question. I'll say, okay, I got this question right, but one of my friends had the same question, and minus 40 wasn't the right answer for him. You can't randomize a question like this, can you? I wonder if ChatGPT will guess possible randomization. So the randomization is making a mistake with regard to the sign. It's not a kinematics question. Okay, but again, this is an alpha testing. This is not a kinematics question. Can you look at the screenshot? I'll make a note of this after this session, so I kind of look at it. Yeah, first scale problem. When my symbolic problems too. Yeah, could have been a temperature. I don't think this is right. because like it's equality is symmetric. So let me just do this. Oh, I guess it asks you. Yes, please. Wouldn't that result in the same minus 40 answer? You flip an equation and nothing changes. It's an equation, not an inequality. Can I remember what it was? So original Celsius. So if the sign is flipped, I don't think I remember the version of the question. Yeah. Yeah. Sure. Answer that. So scan your what was it? I don't have the wording with me. Can you guess? I'll stop with this and then go to a more substantive question. And test its system instructions again with the more substantive question to see, hopefully, that it wouldn't give just the full answer right away to the more substantive question. Swap. Yeah, that doesn't do anything. Kelvin is not Kelvin. Different pair. He might not be guessing it. There's a sign flipping here, so the person reading it makes two mistakes. Mistakes the temperature scale and misreads the sign. Like it's a negative number, but misreads it as a positive number. Offset reading. Yeah, it's not. Yeah. All right. Let me not. Yeah. Okay, so let me find the substantive question and just test the system instructions again to see if it'll do. This might actually be substantive enough. Yeah, it involves multiple steps. So that's okay. I have a new question that I'm stuck on. And again, if the system instructions are working the way they are supposed to, then it shouldn't work out the whole thing for me. It should explain for me the issues that are involved, latent heat of fusion of water, and then I guess, and then applying the specific heat capacity, specific heat to the part B. So it should explain the concepts and give the equations without solving the whole thing. So part A, I think it did that. So I think in the system instructions, I should tell it to, for multi-part questions, do one part at a time. Like it should have really just stopped here and work with you on getting part A right, and then move on to part B. It shouldn't just move on to part B on its own. So let me do part A. So I'm thinking of if there's a mistake I can pretend to make. I think it's a little hard. I can, yeah. So let me just do the multiplication. So no, is that right? Wait. So 6 times 3 is 18, but there's one that's going to be carried over, so 9. Again 18, but there's 2 coming, so this 8 will be, I see. Maybe. So that's A. B. Treat the tree as a lump with specific heat. Not specific. Yeah. It's specific heat. It's divided by. That was heat capacity, but it's specific heat capacity. Temperature change. Yeah. Oh, there's a follow-up question. Does part to be delta T seem physically reasonable for Oh, yeah, I guess. So let me do this. I'll say first. Let me calculate the number. So heat is 2004 divided by the mass 3.215 divided by the specific capacity, and I think that's all in the units. That's gonna cancel out, and kind of no extra conversion needed. So 2.78. So so I'm gonna aggressively round it so that I can mark it as it's wrong. I get 3 degrees C for part B, and the system says it's wrong. Probably it's too small. Should it be 30 degrees? It should correctly spot that this is too aggressively rounded, and it'll tell you it. Put in 2.78 or 2.8. Would the 2.8 be graded as correct? 2.8 should be graded as correct. After this, let me find an ideal gas law question and ask it that. But I'm getting lots of things to fix in about 3 weeks. This is your first and not the last, but last thermal physics question in a while. So the issues is specific here that doesn't really 2.78. If you enter 3, yeah, more precision. Yeah, that's exactly it. Even 2.8 would be within 1% precision that the thing uses. Yeah. Oh, 2.8 was graded as correct. Do you want me to try minus 2.8? No, you should say no because that's a waste of time. Let's go. No need. Yeah. Well, that's good. Yeah, that's a waste of time. Yeah. Good tutor shouldn't have their students just wasting time for no reason. Oh, this can actually be a good question. I must not have written this question. I would have given you a hint that points you to the textbook section. So there's a textbook section that does talk about the mean free path. But I think without reference to the textbook section, I would be lost. This is the kind of thing that you are not expected to drive from first principles. At least not at this level of class. Maybe in upper division or one where you're learning things more thoroughly. So here, that's okay. I have this new question, and I have no idea where to start. Is there a textbook section I can look up? And I believe I haven't covered the mean free path in lecture either, because it's one of those things where once you have the textbook section and the formula, then it's easy, and we don't do much more with it beyond that. Yeah, so this is a caveat warning that it can hallucinate. One, University of Physics Volume 3. So let me actually try this. Sorry, I'm in Physics 4B. It might be that I need to just separate out Physics 4A, 4B, and 4C if there's no way I can kind of prevent it from getting confused about different classes. Then we are in thermal physics. I don't know. It's hallucinating a lot more than it normally does. Oh, maybe I think it's a partial list, but I think at least chapters and those are right. Uh, could you look at the screenshot again? I can paste it again if. No, so right now it's in a hallucination mode, so I'm just gonna try to break it out of that. Let's start over. This is the question: which section in the textbook can help? So you as a responsible user of AI, it's up to you to figure out when it's hallucinating and has obviously given you nonsense. Then read it, recognize it's nonsense, and get it to do the right thing. Mean free path, yeah. Yeah, section 2.3, yeah, that's the key section. The formula. So I do recommend that you actually go to the textbook section, so that next time if you need to find it again without AI's help, then you can find it. But so yeah, let me actually find it this time. So 2.3, is that the right section? Not 2.3. Yeah, it's hallucinated. Yeah, I'm pretty sure it's not 2.3. So it could be 2.2 or 2.1. Gonna guess 2.2. Yeah, again, the warning about AI hallucination. I think the challenging part here is that there is no textbook section that talks about mean free path. But within this molecular model, it actually does. Somewhere there's a subsection about mean free path. So, and at least the formula it gave you, is that the correct formula? I don't think that. So if the lowercase n is n over v, and if the d is 2r, then the formula itself is at least correct. As in, you can plug in the numbers here and you'll get the right answer. But this is another reason to look up the textbook, so that you where correct place to find it. It was in section 2.2. There was a subsection called mean free path and mean free time. Section 2.3 was on something else entirely. Yeah. So here, let me not plug in the numbers. It seems like a waste of time. Let's find an ideal guess law question and work through that, and I think we can let that be the last question. I shouldn't have skipped to the end. I guess the ideal guess law questions are like in the middle somewhere. Wait, did I get any ideal guess law question? These are all. Oh. This might be the ideal guess law question for this set. Feel like I kind of had bad luck with these two questions because they are both kind of boring looking questions. So let me just get a similar question to get hoping for one of the better questions out of the question pool. This is maybe. I'll do that and end the session on that. So here, just finishing up this portion. Yeah, get from the section. Yeah, and it's showing the kind of equivalence of the two formulas. That's okay. I can do that later. I have another question, ostensibly involving the ideal guess. So can I get, let me paste the whole thing. I think if I zoom out a little bit, I can do that. Yeah. So I'll just paste the whole thing in as a way to kind of test. I think it's gonna do the same thing. It'll kind of do A, B, C all together, and I do need to modify the system instruction so that if we see something like that, it only does one part and then kind of engages in a dialogue to work through the whole question. It shouldn't do all the parts right away, even if it's not doing the whole thing for you. Because like, you know, here part B depends on part A, so it makes no sense to work on part B before you finish part A. So comforting structure. Yeah. So it should tell me, oh, I wonder what formula it'll tell you to use. So it should be telling you to use PV equals NKT instead of PV equals nRT, the lowercase nRT. Because in this class, we are only going to exclusively use Boltzmann constant, not gas constant. And that's reflected in the question format too. You will never see moles of gas in our homework questions. It'll always give you the actual number of molecules, even if it looks a little bit high. Did they freeze? Oh. I think this window is unresponsive. Let me just see if I can. Okay, yeah. This just, oh wait. I don't know, this is still kind of unresponsive, so let me just do it here. Yeah, so that's the question that I pasted in. Yeah, it's using the correct form because it knows that from the lecture notes. Microscopic ideal gas law, yeah. I think, well, I guess part is simple enough that, yeah, more than that, I guess it's there are smaller steps for it to break it down into. So let's do part A, and I'm gonna make a mistake of forgetting to convert to kilopascals. This is really, so let me first type it in. So n is equal to, just I'll just use these numbers, 2.8 times 10 to the power of 23 times KB 1.380649. I don't need all the significant figures, but we'll just use it. 23, make it minus, times temperature 298 Kelvin divided by the volume 1.6. Yeah, it converted from liters to cubic meters. Times 10 to the power of 3. Let me. Let me just make one mistake at a time. So that will give me pressure in in pascals. So it's expecting 720 kilopascal, but I'll just put in all the numbers that I see in the calculator. Did I mention this looks unprofessional? I might not have mentioned it in this class. I usually mention it in Physics 4A. So, you know, about rounding, one, don't round so aggressively, you know, like two significant figures, too little, keep at least 3. And really all you need to do is, you know, round enough that, keeping all, whatever, 12 digits or however many this is, 10 digits, that just looks unprofessional, don't do that. But even if you simply round it here at 8, it'll look slightly more professional. I'll start with the A, plugged in all the numbers, and I think I got the powers of 10 right, but it says my answer is wrong. And I think this is a pretty easy mistake for it to spot and fix, that I didn't follow this portion of the instruction about converting it to kilopascal. And you can, so this is the really the advantage of generative AI. So all these homework questions, you have homework help videos. If all you are interested in is the answer, you have access to it. Now, simply copying the answer from there, I don't think that will help you either. But let's say you are trying to work through the homework and you are making mistakes, and you can figure out from watching the homework help videos. At some point, the videos, there's a amount that videos can help, and then the video cannot respond to your specific situation. Generative AI can look at your work, see what mistake you are making, and give you specific feedback on, you forgot to convert to kilopascal. And when it tells me that, unless it tells me the answer also, I'll dumbly say, oh, so I need to multiply by 1,000, and then it'll say, no, you divide by 1,000, and it'll be more gentle about how it corrects me, I think. Let's see. Physics, right? Just don't know why it keeps freezing. Unit slip, yeah. Oh, it gave me the answer. All right, we'll just do that. And yeah, like round it to 3 significant figures. Don't keep all the now. So in citation like this, all these numbers are significant. So that's not unprofessional. What's unprofessional is keeping all the significant figures here when like these numbers clearly have lower significant figures. Only 2, but I wouldn't recommend rounding to 2 because that's too aggressive and you might miss the 1% tolerance. So let's do part B and C. Given the pressure above, what is the magnitude of the force? Right. It was telling me earlier. This is another reason I think I should just do one part at a time. Like scrolling up, that's annoying. Cube, so side is that. Yeah, makes sense. Area is that. I guess that gave me. Also here I can make another unit mistake. So I can just do 720 times the what I get from that. So yeah, so let me actually do it this way. I'm gonna write some stuff down to help ChatGPT or CoA Physics GPT figure out my mistakes. So all those formulas, they're great, they're fine. So the length A is equal to V 1/3 root, and so force is pressure times area, so A squared. I guess I can plug that in and kind of do everything in one step. Pressure times volume to the 2/3. And this is the mistake I'm gonna make. I'm just gonna plug in the numbers as they are without minding what units they are in. So 720 times 1.6 raised to 2/3 power. I'm making 2 mistakes at the same time. Let's see if CoA Physics GPT will sort that out. So 720 times 1.6 raised to power of 2/3. So I'm making mistake in ignoring kilopascal, kilo, and I'm making mistake in not converting liters to cubic meters. So 985. Again, don't copy this the whole thing. Looks unprofessional. Yeah, it's wrong as it's supposed to be. I've been staring at this for 30 minutes and I can figure out what I did wrong. Am I dumb? I don't know if it'll respond to that actually. It'll probably correct, and it's meant to be. I might have taken that out of system instructions about being supportive and all that. Let's see. I might be throwing too many balls at it at once. 2 different mistakes to fix, and emotional support. Let's see which of those balls it catches. I guess it catches the emotional support first. But I might have to, I don't know, something's wrong with the service today. It's just getting stuck. It's gonna refresh because the response is at the server. It's just classic unit rep. Yeah, yeah, that's all right. But yeah, SI units, so liters to cubic meters, and then kilopascal to pascal. Yeah, yeah. I guess you can do 7.20 10 to the 5. Yeah. Oh, it's just giving me the answer right away. Oh wait, what? Oh, I see. There's a, I guess, what, missing factor of 10. Yeah, yeah, yeah. Good. Okay, let's do the part C. Um, so wanna try part C? Use n equals. Wait, what? No, Avogadro's number. Weight of the sample of nitrogen gas. Did they use Avogadro's number up there? It should not be using. Maybe you have to use Avogadro's number. Yeah. So I'll say. Um, oh, I don't think I'm supposed to use Avogadro's number. The professor hates it for some reason. I say this a hint. Can I do this without Avogadro's number? Yeah, without the hint, I think using Avogadro's number is kind of necessary to convert from atomic mass unit to kilograms. And I don't hate it. I just don't want to use it. I mean, I think if you take chemistry class, they will introduce the purpose of Avogadro's number, and that purpose don't apply to us. So I think we should not, deal with the things that don't apply to us. You can do C without Avogadro's number using the hint, yeah, and so you can get the mass of the sample just directly number times the, so this will give you the, 28 times, that'll give you the mass per molecule. So yeah, is it giving me the, yeah, so I do need to modify the system instruction so that it doesn't do that. Yeah, because I think if it's just giving you the full answer right away on the second interaction, then I think a good tutor should be more interactive. So, but I'll wrap up this session here. So that so that I can go home. I got it. Thank you so much. All those answers really helped. I'm being sarcastic, but I don't think it understands I'm being sarcastic. So